Hey there. In this video, we are quickly going to do a very simple machine learning project using the Sonar Mine dataset. You can get the dataset using this link. I will give this link in the description below as well. So first get the dataset and open your Colab. Let me name this as Rock versus Mine. So I hope you know about submarines, which look something like this. So the goal here is our enemy have set some mines. So using a submarine, we are going to predict it whether a object under the ocean is rock or a mine. Okay, so to do that, we have a data set with 61 columns in which 60 columns of our features and the last one column is our label, which which is just two values, rock and mine. Using these features, which is just some decimal numerical values, we are going to predict whether it's a rock or mine. Let's straight away get into the code. First, as we always do, import pandas as p, and let's run the cell. Before that, click here and download the dataset. I have already downloaded the dataset, so let me load it into my Colab where it is. Yeah, now after importing the pandas library, I'm going to load the dataset using pd.readcsv. I'm going to copy the path and paste it. Let's check the first 5 rows of this dataset using df.add. As you can see, there is no column in this dataset. The first row is considered as column, but we don't want that. So in order to remove it, we need to specify a parameter called header, and we need to pass in the value none. And if I run this again, we will have column name as 0, 1, 2, 3, and so on. As you can see, after the ninth column, I'm getting dot dot dot, and then it is starting again from the 51 column. What if I want to see all the columns in this dataset? To do that, we have a function called set option. Here is how it works. pd dot set option display dot max columns comma 100. Actually, we got 60 columns in our dataset. I'm specifying 100, which means we will be able to see 100 columns. Let me do like something like this. Let me give 55 and run this. I need to give it again. Now we will be able to see like all the columns, but you get the point, right? If let me give like 30. Yeah, as you can see, like we get 14 columns and then again dot dot dot, then it starts from 46. If I give 50, I will get 50 columns. Still we got this, but if you count the number of columns, we will have 50 columns. So we got 61 columns, right? So I'm going to give 61. No problem, even if you give more than 61, just the result will be the same. So this is our dataset. Let's understand our dataset by using some functions like info, describe, and shape. Let's know the shape of our dataset using the shape attribute df.shape. This says that our dataset has 208 rows and 61 columns. This is a really small dataset. Now let's know some information about it. We got 208 rows as we have already seen that, and no null values in this column, and all the columns data type are float except the label column, which is object. Let me close this. Let's check if there is any null value in this dataset. We can do that by df dot is null dot sum. This will tell if there is any null value. It seems like there is no null value in any of the columns. If you want to see all if you want to see all the rows, we can do a similar thing like we did before, but this time for the rows. So instead of column, give rows, and you need to run this below this. So there is no null value. Yeah, it's a fresh dataset. We don't even have to standardize our dataset because as you can see, all the values are similar in type. All the values in all the columns are just decimal values with one decimal place apart. So there is no need for standardization, there is no need for handling missing values, and there is no categorical variable. So we can skip all that and we can straight away split this dataset into label, which is the 61th, which is the 60th row, 60th column, sorry, because the column starts at 0, right? So df of 60, and our features are df dot prop. We just need to prop the 60th column. Other than that, everything is a feature. So we got our label, we got our features. Now we need to split this further because we are going to train our model using like 80% of our data, and the remaining 20% we will use it for evaluating our model. So to do that, I need to import a train test split method from the sklearn.model selection module. So from sklearn.model selection, import train test split. After this, I need to create four variables: xtrain, xtest, ytrain, and ytest. And train test split, I'm going to pass in the features, then the label, then I need to specify the test size, which is 20%, which means zero point 0.2, and I'm going to also specify a parameter called stratify. I will tell you what this parameter will do. I'm going to give the value label, and I'm going to set a random state of 56. So if you set the same random state as mine, our split will be similar. So let me run this. Now let me tell you what stratify actually means. Let's say label dot value counts. So we got like 111 instance of mine and 74 instance of rock. We This is not a lot of difference, but in some data set you may have the mine value. For example, say what if the mine value is 300 and the rock value is just 70. In that case, our model will will be trained more on the mine data. so it will not be able to perform well for new instances. Wait. I have clearly written article about this. Here it is. So I have also given a simple example for you to understand stratify. Here it is. So let's say in a school there are 400 girls and 600 boys. If you want to take a sample of 100 from this population, you should take 40 girls and 60 boys. I hope you can understand. There should be equal number of both the, what to say, both the objects or both the values in the label. If there is, when training, we in training, if we have a lot of mine data, mine instance or rows, and a very less rock instance or rows, then the model will be biased towards the mine. This will create some bias. In order to in order to remove this bias, we need to train the model with equal proportions of rock and mine data. That's why I used Stratify. When I use Stratify, when splitting the data, it it takes equal proportions of rock rows with rock and rows with mine. I hope you can understand. I highly recommend you to read this blog to clearly understand. My written English is better than my speaking English. That's why. So after this, I'm going to create a model. First, let's start by creating the logistic regression model. To do that, we need to import sklearn dot linear linear model import logistic regression. Sorry, there will be no space. I'm going to name this model as LR logistic regression. Then I'm going to fit the X train and the void train. So this is the training process. Now the LR model has been trained with the X train and the Y train. Now our model is ready to make predictions. So LR prediction, I'm going to create a variable called LR predict, and I'm going to make the model predict the test. So the original value of X test is the Y test, and the predicted value is the LR prediction. Now let's find out how our model has performed by measuring its accuracy score. Before that, we need to import the accuracy score method from the sklearn.metrics module. sklearn.metrics import accuracy score and LR accuracy equal to accuracy score y test. We need to give the true value first and then the prediction value. Predict, and I'm going to print the accuracy. I get 76 percentage accuracy when using the logistic regression model. Let's try a random forest classifier. From sklearn.ensemble import random forest classifier. I'm going to write all the code in this cell itself. RFC equal to random forest classifier. RFC dot X train comma Y train, and RFC prediction equal to RFC dot predict X test. I'm doing the same thing but using a different model. And then RFC accuracy equal to RFC, sorry, accuracy score of Y test, RFC prediction. RFC accuracy is 80%. Yeah, better than the logistic model. So that's it. So let me give you a overview of what we did. First, we imported the pandas module, then we loaded the dataset, and because there is no columns, we use the header as none so that we, the first row will not be considered as a column, and instead we will have some numbers as columns. Because we were not able to see all the columns, we used a function called set option, and now we will and set it the max column as 61, and now we will be able to see all the columns. And then we took a look at our data set. We got to know the shape, then some informations. Then we checked if there is any null value in our data set, and then we divided the data set into features and labels. After that, we splitted the features and label further into training set and testing set, and then we created a model, and we haven't done any data pre-processing because there is no null value in a data set, there is no categorical data in a data set, and there is also the data set is already standardized, so the workload was very less. And then we straight away moved to the model building process, and we first built a logistic regression model, and it gave us an accuracy of 76 percentage. And then we used a random forest classifier model, and it gave us a accuracy of 80%. That's what we did. I hope this video was helpful. Thanks for watching.